So my objective in this demonstration is to show and apply the uniform random numbers to calculate the area under a curve, interestingly. So I build the problem step by step. Let's dedicate one cell for writing the text. So distribution of random numbers in 2 dimensions. It's like on a plane. So first I have to import the library numpy as NP and import matplotlib.py plot as plt. Now I say n equals say 100 and I say x equal to, okay, by the way, let's set x equals 0, y equals 0. Now I say for I in range n, I say x equals numpy random dot random, one random number at a time, and y equals numpy random dot random, and let's simply plot it. Plot x, y, take the coordinates and plot it as a blue circle. And that's it. And on one figure, let me set the scales PLT plot XY as a circle and PLT x limits from 0, 1, 0, 1, and PLT y limits 0, 1. Because random numbers are between 0 and 1, so I have set the frame to hold all these values. So is there any command confusing to you? I started with n points. I said x equal to 0, y equal to 0. Then I plotted the first point to make the frame. And then in a loop, I generated x, a random number, y, a random number, and then plotted those random numbers, right? Let's see the output of it. So we have got a plot, right? So by uniform, we mean like the uniform charge density. So I think all of physicists have this concept of uniform line distribution, uniform disk, uniform spherical distribution. So on a piece, so we have these numbers, and if you plot it one by one, I will show you in the next time. So it will look like a movie that you are throwing the darts on a board, right? And they fall on randomly. Now, I formulate a problem and I count the number of points which falls in a particular region, right? Particular region. So for example, let's consider a unit circle. So this is going to be the first quadrant of the circle is going to fall in this graph, right? So now let's highlight the number of points which are below this one. So instead of this line, after instead of this program line, I say, let's compute the distance of every point from the origin, right? In first coordinate, it is equal to numpy sqrt. It is should be x squared. In Python, it should be written like this: x squared plus y squared. So one calculation. So compute the distance, right, from origin, right? Every point it is computing, it is being computed. Now I say if the distance is less than or equal to 1, right? If the distance is less than or equal to 1, so then I say plot PLT XY with red color, and else plot it like the default we set. We have to be very cautious about the indentation. Okay, let's correct it. Yes, this variable should be correct. So I have computed the distance of every point from the center, right? And said if it is less than one value, then plot it with a blue color. So let's see the whether the distinction has been made or not. Only graphically, right? So I have made a distinction. Now, the total number of points are n. And there are blue points, total number of points, blue and red. And we have red points which are below the curve. So below the curve points are proportional to its respective area, and the total number of points are proportional to its proportional area, right? So here, let's do the journal counting. जैसे मैंने कहा कि मैं इसे कहूँगा n red. Let's count it. N red equal to 0. So these are the points which are inside the circle. So I say when the point is red, so I say n red equal plus 1. We can write it in Python like this: plus equals 1. Let's write it conventional way. N red equal to n red plus 1. The conventional way. Update the count, right? So reds are counted. Now the area calculation problem. Now area computation. So area computation के लिए let's write area of the region. Area of the region will be equal to area of square. So for unit square, the area is 1 times the n red divided by total n. So this is the area of the region, right? And from here, the area of circle, I say a circle will be equal to 4 times the area of region. Where this one, n red over n is the probability. Number of points hitting below the curve divided by the total number of points in the region. Total is the whole domain, and the red points are here. So this is the definition of probability. N red divided by n. It is the probability in hitting below the curve. And now let's see the answer. There are no errors, which means master is doing something correct. And now let's see the answers. Behold, no cry, and hold your breath. Area of circle, a circle. 3.14. Area of unit circle is pi. Monte Carlo pi is correct to 2 decimal places. And you will have the video. Watch it as many times as you like. Today, forget about Atif Aslam. Remember Dr. Rizwan Ahmed and Monte Carlo.